Hello. Today I wanted to talk about moving balls in like 3D space. Now, I'm gonna draw like a horizon, or just think of that as like the horizontal vanishing point. Sorry if my audio is a little bit bad. Um, my PC is not the most expensive one, and sometimes the fan kind of runs pretty loud, so it kind of messes with the audio quality. I also don't have the best microphone or like one of those sound deflector things, but I'm pretty sure it would still cause the bad quality. Okay, but here I have some balls. It's just an image of some like bouncy balls. So I wanted to like put that in perspective of like what we're talking about here. So let's say you're looking at like one of these balls, not thinking of the patterns, like top down, right? So this is like a three-dimensional form, and when you're looking at it, I'm gonna draw another one of those. Um, ugh. And when you're drawing one of them, sorry, when you're drawing one of them, if you're looking at it from like a top-down perspective, it's going to like it's just gonna look like a circle. But the important thing to know is that this is like a 3D form. So like, like I said, we're looking at this from above. Okay, but let's say, well, I guess that was a bad way to put it because I have the vanishing, or the horizon here. So it would just look like a circle from above. And if you're looking at it, like, if it's like perfectly on the horizon, it's just like that. So the important thing to know is that there's a series of cross sections within this ball, or ellipses. So like, because we're looking at it straight on, it's kind of like that. If we were to like kind of think about how it contains ellipses in 3D space, like let's say you took a knife, or like I think a box cutter is a better idea because you can get like thin cross sections. And if you were to like take apart this ball, you would effectively have you would have this, right? You have like a cross section that's like, it looks like a line if you would cut it perfectly and you were looking at it like that perfect, like it would look like a line. But if you would like take that line and kind of like lay it down, it would just look like a circle. But like, if you're to go back to this ball, okay, so like at this point the ball is missing that center. So because it's missing that center, you're gonna have, and please just bear with me because I'm not going to be doing this perfectly, you're going to be like, bleh. You're going to be having like, you're going to have, bleh, sorry, I thought I warmed up today. You're going to have like a cross section here. Not a cross section. You're gonna have, you now have like two halves of a ball, and it's kind of weird to deal with because that section we had is now over here. So the other thing is, assuming this ball was like perfect at this point, like let's say we're gonna cut it again. So let's say we take our box cutter and we make another slice. We make another slice. And make another slice, and make another slice of it, and another, and another. And really, depending on the thickness of the box cutter, I mean, you could pretty much do this to, well, I mean, it couldn't be forever, but I guess depending on the knife, it could be like to infinity. So at this point, let's take this section. This section, well, obviously, it's going to like just look like another chunk again, or looking at it straight on, it's just going to be a line. But the reality of it is that it's like another circle cross section, and we take this chunk. But the important thing to note here is that these chunks are getting like a little bit smaller each time. This is not to scale, but look, every chunk that we do is like another ellipse circle. But like, it's getting smaller because the ball is only so big, and it does like kind of taper off. So Sorry, I spit on my screen. Every ellipse of the ball is getting smaller and smaller, and I'm going to do that one again. And smaller, and yeah, that was too big. This isn't perfect. Please bear with me. And then you have another section, and like it's just getting smaller because we effectively took our bouncy ball, and we cut it, and we laid it on the other side. And that's kind of how, like, you could kind of visualize the cross sections. Like, I guess you could visualize like a ball as like a series of ellipses that, like, there's a center point and it's like the largest point, and is there a word circumference? No, I'm thinking that wrong. Maybe I'm thinking it right, but like it can keep getting smaller. So I wanted to like think about, going back to like our horizon vanishing point. And let's say we have that ball again, right? So this is just another ball. And, you know, it's kind of hard to depict like how it sits in 3D space, because, you know, as far as we can see, it's just a circle. And like when you're drawing that, it's a bit weird because, like, look here, you can clearly visualize that these balls are like three-dimensional in nature. You can detect that, I would say, because of the patterns on it. So there are many ways to depict how a ball sits in 3D space. So like if you look at like this ball here, look, they put like it's hard for me to say. I'm guessing what they did is they had a mold. Like if you could think of like a mold that contains like two parts. You know, let me draw it for you, because why not? Like, I think the term you could think of it would be like an injection mold. The only reason I know that is because I dealt with plastics fishing lures a long time ago. And kind of a way what you would do is you would have like a bottom half. Or you'd have like half of the ball, and please forgive me for all these little mistakes. You'd have a bottom half, and then you'd have like a top half, and there's usually like a divot here and here, and you could think of these as like both of these are the same perfect thing. And there was usually like some type of handle here, and then you would like you would pretty much close it, so like you really couldn't see it, but effectively there was like a hole where you could pour your plastisol, or like, I don't know, whatever type of liquid hot plastic you would pour in here. And effectively what it would do is it would create the 3D model, or it would just like, it would fill it completely. There were methods to, I'm not going to go down that rabbit hole, but just know that like when you injected the plastic into here, it would eventually create like a ball like that. How they do the patterns with the other balls, I'm not really sure. I'm guessing like for the one that looks like tie-dye, or the two that look tie-dye, they did something special. The ball that has a bunch of squares on it here, I have no idea what magic they did. I'm guessing they probably had to like sell their soul to the devil to make it. No, I'm just kidding. Where was I going with this? Okay, so let's take a look at the ball over here that was two halves. So let's say this one was red, or, you know, if you look over here in our injection mold thing, you have, I'm being stupid, I'm not going to go with red. I'm going to go with, this one's going to be yellow, and this one's going to be pink. Why? Because I want it to match the ball over here. So we have our ball, over here, we have our finished ball, and we let the plastic cool to room temperature, and now it's a solid form like that. So let's say we pop it out of the mold and we have, well, what do we have? We have a ball. But, okay, think of this. Okay, think of everything we've learned so far. It has two halves. Where? Well, let's match it up. Okay, I'm going to draw an ellipse through here. So here's the other important thing to know, and it's hard to match it one-to-one because I am trying to match it one-to-one. This section is the yellow section, and this section is the pink. Because effectively, you know, since this was an injection mold, and I'm just kind of assuming we kind of kept it separately, and I don't know, they probably let it cool off, that this thing here is like the same thing as that. So what we have established here is that we have two halves, the pink half and the yellow half. And we have an ellipse that's going through this ball to show that there are like two halves to it. And I'm going to kind of try to do that more perfect, or however you say that. But the important thing is, look, I'm drawing a partial ellipse here. This isn't like a full ellipse. And I guess like the issue here is if you look here and here, there's kind of like a wraparound, and basically this partial ellipse kind of it kind of shows the three-dimensionality of it. But like the issue that we're having is like if you look at the ball in reality, you're not seeing this this ellipse wraparound, because basically we're drawing through this 3D object. So I'm going to erase a part, and I'm just going to use the color white to erase it. The important thing to know is that I'm going to make the ball look more similar to the one on the left. So like if you look at it close enough, this is and if I get rid of all this other crap here, but I'm not trying to do this 100% perfect. But if you look back at this here, it looks a bit more similar as we're dividing like the yellow and the pink, because like the reality, you're kind of seeing this, or sorry, let me draw another arrow to it. Like in reality, you can't see the full ellipse because the actual bouncy ball here is a 3D form, and we don't have X-ray vision to kind of look through it and visualize the ellipse, or that's probably not the best way to say it, but you can't visualize it. So like the benefit of actually drawing is that you can better represent 3D forms. I mean, obviously, like if you made a bouncy ball that was like translucent and put an ellipse through it, you probably could get away with that, but I mean that's probably a lot of work and a bit complex. Doable, but like with actually drawing it, you could portray that. Now there's another way to portray this. You do not have to draw what I like to call the partial ellipses. I mean, it is beneficial, I'd say, because sometimes drawing full ellipses, I mean, it's the same idea, but let me draw it again as I run out of canvas space. Okay, ready? Get ready for this. Or, watch me fail a couple times. Okay, so there's an ellipse here, which is like this ellipse here is the same as this one over here. So these are both the same. They should be the same degree. I'm kind of just botching exactly how it would look, but you could think of it as like a slice. Like, much like a slice of pie, this is an ellipse. And, like, you could say that, I would say that because of this ellipse here, or, this one right here, this, like, center thing that I just drew, this ellipse, this would match up to our biggest circle because, I'm assuming it's, like, directly in the center of the ball. So, like, that ellipse there, it's matching up to the center. Sorry for coughing in the mic. But it matches up to the center. So like if you think of, I'm gonna draw that ellipse again. We're just assuming like that it's that it's like a perfect cross section. So watch me fail. So if you would you know, we took that ellipse and we had it over here, and let's say we like cut another ellipse, right? Well, and it's not exactly as perfect as I want it to be because I'm not the most perfect drawer with all of this yet. And if you take it and it's like that one's there, and like you take another cross section, this is not the scale, and you do it again, and you know, you just keep doing that, and basically like those are the sections of the ellipses. So far we've seen using showing three-dimensional space in a ball using partial ellipses and then full ellipses. So going back to our horizon line, I want to make another horizon line again. So we've depicted using ellipses, or partial ellipses, full ellipses. Now, thinking of it at the horizon, since we have a ball here, there is another way to depict kind of how it's coming towards you in 3D space. One way is size, because look, now let's assume both of these balls are the same size, but this ball here is closer to us in 3D space. So like it's physically closer to us. Maybe it's better for me to like draw another ellipse for them. But it's kind of hard to depict it. You know, I'm guessing there's a lot of ways to depict how to draw these. I mean, if you really think about it, if you didn't want to cut the ball kind of like directly in the middle, I mean, you could cut it this way, or you know, you could cut it this way. The circumference. I was thinking the circumference. But sorry. You know, you can cut it that way, that way, that way. And here's the other thing. It could be helpful sometimes to depict like a light source, because, well, depending on how close the ball is to you, like let's say there's a light source behind us. So the light source would hit, let's say maybe like, you know, since it's like directly behind us, it would hit like there, and maybe let's say the ball is shiny, or it's like you blew a bubble from like a ball from like a tube of bubbles that you can, like, you know, if you had one of those like wands or whatever, and like this here's our light source, so we can tell that well, I guess it's just kind of like another way to depict the curvature on the ball. So like it's interesting how the light kind of conforms to like the surface, or like from our perspective how we're looking at it. So as we've talked about the ellipses and depicting how close it is to us in 3D space, it's also important to know that like in like how they depicted these patterns on here, if we had another ball, you would know that the ball has like a curvature to it, so you could like draw patterns on the balls. And the important thing to know is that like in the case of that ball, you know, some of the square things are kind of getting cut off as you go. Like you could see them, and I'm drawing over here, by the way, if it helps. But know that like all of these squares, like there's like a curvature to them on the actual ball. This can actually be helpful if you're like trying to learn anatomy, or like trying to draw like, I don't know, face features, because like everything's kind of conforming to not a perfect circle, but like conforming to a surface that's like ellipsoid. But the point I'm going to show you here is over here, note that there's kind of like a twisting because it's kind of going that way because you're following like the curvature of the ball. And sometimes it can be a bit difficult to depict because eventually, like in this case right here, this thing that I drew here, right here, it's important. I'll make it larger. Please annoy the pixelation. Because like this line is straight because like it's directly faced towards us. And you know, obviously it would look like a line going back to like the way the ball was divided perfectly in half. If it was and we were looking at it from that perspective, it would kind of be like that. Or I guess it would be better not to draw all the way through it, but kind of like that. So yeah, always be wary of like how things wrap around the curvature of the ball, and like as long as you keep that in mind, there's a lot more that you can like do with balls. I want to touch upon one last point in this video. If we were to have like a horizon and you were to have like two balls, we have one ball here and we have one ball here, right? Okay, so this is going to sound a bit weird. This ball is behind, yeah, that ball's behind, like this is the behind one, and this one's in the front. So you may be wondering, you know, how to depict that. Well, there's another way. I'm gonna use the eraser again. Because the behind ball, obviously because it's behind the front ball, you know, you can't always see the horizon through these things. But the thing is, you know, you wouldn't be able to see any of the behind ball behind the front ball. So that's kind of like another way you can depict how things sit in 3D space. You know, you have ellipses, you have order, thinking of how the viewer is looking at it. You can mess around with light sources. You can mess around with curvature to depict like how something sits in 3D space. So yeah, those are like the main ways. I hope my video helped you with it. If you have any questions, please ask in the comments and I could like elaborate on it or make another video to answer questions. But yeah, thank you for listening. And don't forget to like and subscribe the video. Thank you.